This is the exam review for your second exam. So let's look at number 1. It says find the distance between the points P1 and P2. So using that distance formula and labeling x1, y1, x2, y2, we have the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So that distance is equal to the square root of 6 minus 4 squared plus, now let's do the y's, 4 minus a negative 3 squared. This would be square root of 2 squared plus 7 squared, or the distance is equal to 4 plus 49, which is the square root of 53. Now, this is the exact answer. If you want an approximate answer, put that into your calculator and you will get approximately 7.28. So that is the approximate answer. Number 2 is asking us to find the midpoint. If you'll remember, the midpoint is an average of the x's and an average of the y's. So I have x1, y1, x2, y2, and that midpoint is a point where I add my x's, so negative 4 plus 2 divided by 2, that's how you get the average, and then my y's, negative 3 plus 2 divided by 2. That's going to give me the point negative 2 over 2, negative 1 over 2, or the point negative 1, negative 1/2. So the midpoint is negative 1, negative 1/2. It's just taking an average. All right, and number 3, it's asking us to plot the point and then plot the point that is symmetric to it with respect to A, the x-axis, B, the y-axis, and C, the origin. The point is 4, negative 2. So 4, negative 2, to plot that point, and I'm going to use different colors here so you can see, 4, negative 2 is right here. So we want to plot the point that is symmetric to the x-axis. So I'm going to flip that across the x-axis, and we have the point 4, positive 2. So what changed to go across the x-axis was the y. Now we're going to plot from this original point, we're going to plot it with symmetry to the y-axis. So that would go over here, negative 1, 2, 3, 4. That's across that y-axis, and that is the point negative 4, negative 2. So what changed with respect to the y-axis was the x. And now to the origin, it's going to go across and up here. Oops, I did the same color. That's okay. Let me change that real quickly so you can see that one differently. It's right here. So that takes it across the origin, and you can see that I am at the point negative 4, positive 2. So it changes both the x and the y. And that's all you're asked to do for that, just to show that you understand symmetry. All right, on the next page, it says number 4. For the equation given, list the intercepts and test for symmetry. All right, so first off, to find an x-intercept, remember, we let y equal 0. So in that case, what I'm going to do is in an xy table, I'm going to let y be 0. That would give me x squared minus 4 equals 0 because this y becomes a 0. Or x squared equals 4 if you add the 4 to both sides. Now we're going to take the square root, and that's going to give me plus or minus 2. You want both. So it's 2, 0 and negative 2, 0. Those are the intercepts. For the y-intercept, you let x equal 0. So that would give me, with x being 0, 0 minus y minus 4 equals 0. If I add a y to both sides, I get y equals negative 4. So I can put my negative 4 right here, and my y-intercept is the point 0, negative 4. So this is not different than what you have done in prior courses for finding intercepts. Now, let's look at symmetry. To find symmetry to the x-axis, I'm going to make a little, sort of a little chart here. You replace y, then I'm going to write with, you replace y with negative y. So what that would give me is x squared minus, take out that y and put in negative y minus 4 equals 0. Or that gives me x squared plus y minus 4 equals 0. Is that the same as my original equation? Well, definitely it is not, so there is no symmetry to the x-axis. Now let's, again, I'm going to use colors here to help you because there's not a lot of space here. To find symmetry to the y-axis, you replace x with negative x. So let's do that in purple. So that would be negative x gets squared minus y minus 4 equals 0, but that's just x squared minus y minus 4 equals 0. Is that the same as the original equation? Yes, it is. So there is symmetry to the x-axis. In green, let's test symmetry to the origin. That is where we replace x with negative x and y with negative y. So that would be negative x instead of the x squared minus negative y minus 4. And I think you can see automatically that you are not going to get the same thing. So no, there is no symmetry to the origin. All right, in number 5, it says find the equation of the line. And so what we are going to do is use these 2 points. I have the point negative 1, 1. And 2, 2, I'm going to call this x1, y1, x2, y2. I'm going to, like we always do, go over in the margin, write x, y, m, and b. I'm so far in the margin you can't see it. I can choose either one of my x's and y's. I'm going to choose this one because it doesn't have any negatives. I don't have slope, but I can certainly find that using the slope formula. So y2 minus y1 over x2 minus x1. Watch your signs. Or 1 over 3. So my slope is 1/3. Now, I can use those 3 pieces to find the other one of these 2, because these are the 2 I need. So we write y equals mx plus b. Fill in what we know. 2 equals 1/3 times x plus b. 2 equals 2/3 plus b. Subtract a 2/3 from both sides, and you get b equals 2 minus 2/3. So let's think about that. 2 over 1 minus 2/3. I need a common denominator, which is 3. That gives me 6/3 minus 2/3, which is 4/3. So now I have the b. I can put it all together. Y equals mx plus b. So always having to find the m and the b. It says find an equation of the line with the given properties and express your answer in slope-intercept form. Now, most of you know I prefer the slope-intercept method. If you want to use the point-slope method, you go right ahead. So I've got x, y, m, and b again. My x and y are right here. X is 1, y is negative 1, my slope is negative 2/3. I was given that. I didn't have to find it. So all I'm left with having to do now is finding the b. So y equals mx plus b. Negative 1 equals negative 2/3 times x plus b. Negative 1 equals negative 2/3 plus b. I added 2/3 to both sides, and I get b equals negative 1 plus 2/3. Once again, I need an LCD. So negative 1 over 1 plus 2/3, it's 3. So negative 3/3 plus 2/3 is negative 1/3 is my B. So my equation is y equals negative 2/3 x minus 1/3. Don't use double signs. Don't write plus minus. It just makes a minus. All right, if my equation is horizontal, then that means the slope is 0. And I know that horizontal equations are y equals, all I have to do is look at that y, and I have it. There's nothing to do there. On this last one, it says perpendicular to this line and containing this point. So x, y, m, and b again. My x is negative 3. My y is 0. I don't know the slope. However, if I found the slope of this line by rearranging the equation, y equals negative 2x plus 2, I know the slope of that line is negative 2. If my line is perpendicular, it is the opposite reciprocal, so my slope is positive 1/2. And now I'm back to doing what I've been doing in the two problems above. Y equals mx plus b, so 0 equals 1/2 times x, which is negative 3 over 1, plus b. 0 equals negative 3/2 plus b. Add a 3/2 to both sides, and b equals 3/2. So I put it together, and I have y equals mx plus b. That was actually a very easy one, provided that you remember perpendicular lines have opposite reciprocal slopes. On the next one, it says find the slope and y-intercept of this line. So if I can get it into y equals mx plus b form, then I can just read off the slope and the y-intercept. So I need to get it solved for y, so I'm going to subtract a 1/3 x. That gives me y equals negative 1/3 x plus 2. So I now know that my slope is negative 1/3. And my y-intercept, now don't say that it is 2 because that is not correct. It's the point 0.02. So there we have the y-intercept and the slope. All right, the next one says write the standard form of the equation of the circle of radius r and center hk, and then graph the circle. So we know that the standard form of the equation of a circle is x minus h squared plus y minus k squared equals r squared. And I have my h, I have my k, I have the r. So it's just a matter of plugging in. So it's x minus 1 squared, remember this stays in x, plus y minus 0 squared, we'll clean that up in a minute, equals 3 squared, or x minus 1 squared plus y squared, y minus 0, equals 9. That is the standard form of the equation. Now I'm going to graph it. I know that the center is at the point 1, 0, so the center is right there, and the radius is 3. So we count over 1, 2, 3, 1, 2, 3, 1, 2, 3, and then down 3, 1, 2, 3, and then you just sort of sketch and fill in, rounding that out the best you can. It's not an easy thing to do, but there you go. That's close enough. On the next one, it says find the center and radius of the circle and find the intercepts and then graph the circle. Now, this one is a little tricky. I can't say that the center is negative 1, 1. I can't do that because of those 3's. So I have to, the standard form of the circle is this. There's no number in front of the x or the y parentheses. So I'm going to have to divide each term by 3, and I get x plus 1 squared, because those cross canceled, plus y minus 1 squared equals 2. Now I can find the center and the radius. So the center, which is the point HK, remember it's the opposite of what you see, is negative 1, 1, negative 1, 1. The radius is square root of 2, which is approximately 1.414. It keeps going. All right. Now let's find the intercepts. Let's find the x-intercept first. That means we let y be 0. So that would be x plus 1 squared. If y is 0, then I would have just negative 1 squared, because it would be 0 minus 1 equals 2, or x plus 1 squared. Negative 1 squared is just 1 equals 2. Subtract a 1 and I get x plus 1 squared equals 1. Now I have to take the square root of both sides. And what I get is x plus 1 equals plus or minus 1. So we're going to split this. X plus 1 equals positive 1, x plus 1 equals negative 1. I subtract it here and I get x equals 0. I subtract it here and I get x equals negative 2. So what does that mean that my x-intercepts are? It means that I have the point 0, 0, because that's x is 0, and I let y be 0 here to find it. And I have the point x is negative 2. 0. So those are my x-intercepts. Now we want to find the y-intercept. So I'm going to do that down here. I'm kind of running out of room. Y-intercept is where we let x be 0. So going back to my equation, that would be a 0. So it would be 1 squared plus y minus 1 squared equals 2. Or 1 plus y minus 1 squared equals 2. I'm going to subtract a 1 from both sides. That gives you y minus 1 squared equals 1. And I'm now going to take the square root of both sides. Now, the other thing you could have done at this point is you could have FOILed that out and then factored. I actually think this is easier. And so what we have is y minus 1 equals plus or minus 1. So if I split that, let's split that into 2. I have y minus 1 equals plus 1, y minus 1 equals negative 1. I add a 1 to both sides. I get y equals 2 and y equals 0. So in this case, my y-intercept is the point x is 0, y is 2, and x is 0, y is 0. This is a y, not an x. So you can see your two intercepts there. Now, how does that help me graph it? Well, I'll show you. Because this radius isn't one I can count off, I know that the center is at negative 1, 1. So the center is right there. But it's hard to say, well, let me go over 1.4, up 1.4. That's a difficult thing to do. So I can look at the intercepts. It goes through the point 0, 0. It goes through the point negative 2, 0. And it goes through the point 0, 2. So if this is the center, my circle is going something like that. So it helps graph it just a little bit. So remember, for x-intercepts, you let y be 0. For y-intercepts, you let x be 0, which is what I did on each of those. All right, looking at the next page, we're going to be looking at some functions. So starting with number 12, it says, which of the following are functions? So let's look at the first one. This is a graph. All I have to do is a vertical line test. It crosses in two places, not a function. For B, I can actually do a mapping if you would like. So x's and y's. My x's are 2, negative 3, and 4. I don't need to repeat the 2. The y's are 6. Don't repeat the 6. 9 and 10. And now let's map. 2 goes to 6. Negative 3 goes to 6, that's not a problem. 4 goes to 9, we're good so far. And then 2 goes to 10, that is a problem because the 2 is going two places. So that one is also not. Here I can just look, 1 goes to 3, 2 goes to 5, 3 goes to 3, 4 goes to 8. Each x only goes one place, so that is a function. And for this one, in C, I am going to do the same thing that I did for B. So my x's are 1, 2, 3, and 4. 1, 2, 3, and 4. My y's are 3. So 1 goes to 3, 2 goes to 3, 3 goes to 3, 4 goes to 3. But every x only goes one place, so this is also a function. So the functions are C and D, and that's exactly how you would do that question. You have to check each one. You can't just guess. All right, number 13, it says find f of 0, f of -1, f of -x, negative f of x, and f of x plus 1 for this function. So we're going to go through all of those. I'm not going to recopy the function this time. F of 0 equals, I know that means put a 0 in for my x. So it's going to be 3, 0 squared, plus 2 times 0, minus 4. 3 times 0, 2 times 0. So f of 0 is just -4. That one was an easy one. F of -1, same thing, but where the x's are, we're going to put in a -1. So 3, take out the x, put in a -1 square, plus 2, take out the x, minus 4. Squaring first gives me 3 times 1, multiply, minus 2, minus 4. Or 3 minus 2 is 1. Minus 4 is -3. So f of -1 is equal to -3. I hope you see what I'm doing. On this one, wherever there's an x, I'm going to put a -x. So it's going to be 3, take out the x, put in its negative, plus 2, take out the x, put in its negative. Negative x squared is still x squared, so this is going to be 3x squared. 2 times -x minus 2x minus 4. So f of -x is equal to that. Okay? Now we want, this is the one you got to be careful with, the negative of f of x. So that means the negative of the whole thing. 3x squared plus 2x minus 4 is equal to -3x squared minus 2x plus 4. It effectively changed the signs on each piece, each term. Here I have to fill in the x plus 1 for the x, so it's going to be 3x plus 1 squared plus 2 times x plus 1 minus 4. Now remember, this is a FOIL, x plus 1 times x plus 1. So make sure you FOIL that out if you can't do it in your head. It's going to be x squared plus 2x plus 1. I can distribute this, plus 2x plus 2 minus 4. Distribute the 3. 3x squared plus 6x plus 3 plus 2x. I can go ahead and do minus 2, plus 2 minus 4. Combining like terms gives me 3x squared. 6x and 2x is 8x. And then 3 minus 2 is 1. And where you will mess up here is right here, remembering that you have to write that twice and FOIL it. All right, let's look at some function problems that have to do with domain and domain restriction. So here we are looking for the domain restriction. So the domain restriction involves a denominator or something under a radical sign. So I know here that x squared minus 16 cannot equal 0. We're going to add a 16 to both sides. X squared cannot equal 16. Take the square root. X cannot equal plus or minus 4. So the restriction is x cannot equal plus or minus 4, which means the domain is the set of all x such that x does not equal plus or minus 4. These two are almost the same, the way you write them. This is what x can't be. This is what x can be. On this one, I know that what's under the radical, so 1 minus x, must be greater than or equal to 0. If I add the x to both sides, I get 1 must be greater than or equal to x. Turn the whole thing around. X must be less than or equal to 1. So the restriction is that The domain, and there's several ways to write this, is the set of all x such that x is less than or equal to 1. That's the easiest. Or you could say it's negative infinity to 1, including that 1. That's another way to say the same thing. On this one, I don't have a denominator containing a variable, and I don't have a radical. So the domain restriction, there is none. So the domain is negative infinity to infinity, or you could say all real numbers. I'm going to abbreviate that. All real numbers. So that's domain restriction. All right, continuing on to our next page, we have some more with functions. It says if f of x is equal to x minus 1 and g of x is equal to 2x squared, find the following, f minus g of x. Well, we know from our function operations that that's equal to f of x minus g of x. Well, f of x is x minus 1 minus g of x is 2x squared. So basically, I just want to put that in the correct order. Negative 2x squared plus x minus 1, because this is a positive. So that one, there wasn't much to do there. F times g of 2 is equal to f of 2 times g of 2. So I need to find each of those. So let's use different colors to do that. So for f of 2, I'm going to go back to my f of x function, and I'm going to put in a 2. So f of 2 would be 2 minus 1, or f of 2 is 1. So that's the first part that I need. And then to find g of 2, I'm using this, is 2. Take out the x, put in a 2, square it. Or g of 2 is equal to 2 squared is 4 times 2 is 8. Now what I want is I want f of g of 2. So it's going to be f of 2 times g of 2, or just 8. That one wasn't very hard either, actually. This is an important one. There's a lot of points involved in this if you see this on your test, and you will. So let's go through this slowly, making sure that you understand each of the parts. So we're given a function, f of x equals 2x squared minus x minus 1. And we're supposed to answer the following questions. Is the point negative 1, 2 on the graph? That means if I let x be negative 1, will I get 2 for y? So we're going to say 2, take out the x, put in a negative 1, minus x, take it out, put in a negative 1, watch your signs. That is going to give me 1 squared is just 1. It's going to give me 2, change and change, plus 1 minus 1, which is 2. So when I put in negative 1, did I get 2? Yes, I did. So that point is on the graph. If I had gotten anything other than 2, the point would not have been on that graph. If x equals 2, what is f of x? So this time I'm going to put in a negative 2. So f of negative 2 would be 2, take out the x again, watch your signs. So this is going to be a 4 times 2 is 8 plus 2 minus 1, which is 9. That is f of negative 2. So then it says what point is on the graph? Well, when x was negative 2, y, or f of x, was 9. So the negative 2, 9 is on the graph. Don't forget that part of the question. This one is different. This is the one that people have the hardest time with. If f of x is negative 1, what is x? This is like, if this is the answer, what was the question? So this time I have to take my function 2x squared minus x minus 1, and I set it equal to negative 1. Well, to solve that, I'm going to get it equal to 0. That gives me 2x squared minus x equals 0. And now I'm going to factor. So factor out the GCF of x times 2x minus 1 equals 0. I'm going to use the 0 factor property, either x equals 0 or 2x minus 1 equals 0. Solve that by adding a 1 and then dividing by 2, and I get x equals 0 or x equals 1/2. Now you're not finished because it says what points are on the graph. Well, here's the points. X is 0, y is -1, and x is 1/2, y is -1. So those are the 2 points that are also on the graph. So don't forget to go back and take what you found and answer that second question. D, what is the domain? Well, let's go back to the original function. There's no variable in a denominator. There's no radical. So it's all real numbers or -infinity to infinity. There's no domain restriction. The X-intercepts, that is when y is equal to 0. So I take 2x squared minus x minus 1. I set it equal to 0. So this is let y equal 0 to get the X-intercepts. That is factorable, long process. Let's see if it is. Are there factors of -2 that combine to make -1? That would be -2 and +1. So bring down, break down, bring down, group 2x times x minus 1. There's a 1 in there. It got covered up. Plus 1 times x minus 1. So my two factors are x minus 1 and 2x plus 1 are equal to 0. So either x minus 1 equals 0 or 2x plus 1 equals 0. I solve those. I get x equals 1. That's one of the x-intercepts. So that would be X-intercept. Let's write that right here. That would be the point 1, 0. And here when I solve and divide by 2, I get the point -1/2, 0. So there are those X-intercepts. The Y-intercepts are much easier because to find the Y-intercepts, we let x equal 0, and in a function like this, that's real easy to do. So I just want f of 0. So it's going to be 2, 0 squared minus 0 minus 1, or f of 0 is equal to -1. And you know, we actually already knew that because look right here. We already figured that out up here. So I know that my y-intercept is the point 0, -1. And if you happen to notice that you already had figured that out up here, then you can just write that answer there. That would be perfectly legit. All right, let's do another one of these because I think these tend to be the harder part of this exam material. So if f of x equals 2x over x minus 2, we're going to do the same thing. Is the point 1/2 -2/3 on the graph? What we care about is that. That is the x. I'm going to plug that in for x and see if I get -2/3 when I do it. So that would mean I'm looking for f of 1/2, which would be 2 times 1/2 over 1/2 minus 2. Well, that gives me 1 over 1/2 minus 2 is 1/2 minus 4/2. Okay, because that's going to be 2 over 1. You find an LCD. So you're going to end up with 1 over -3/2, which is, let's move over here, 1 divided by -3/2. Keep, change, flip, and I end up with -2/3. So that's what I was supposed to get. So is that point on the graph? Yes, it is, but it was a little harder to check than the last one we did. If x is 4, what is f of x? So I want f of 4. That would be 2 times 4 over 4 minus 2, or 8 over 2, which is 4. So what point is on the graph? The point 4, 4 is on the graph. This is the hard one. If f of x equals 1, what is x? So I take this and I set it equal to 1. So 1 equals 2x over x minus 2. How do we get rid of a fraction? Multiply by the LCD, which is that denominator. That gives me 1 times x minus 2 equals 2x. I'm going to subtract an x, and I get x equals -2. That was an easy one. So what point is on the graph? -2 is the x that I just found, and the y is 1. So there is the point that we found. What is the domain? Now let's go back to the original. Whoops, be nice if you could see it. There is a variable in the denominator, and you can see by inspection x cannot be 2. So the domain, since x cannot be 2, the domain is the set of all x such that x is not equal to 2. The X-intercepts are the hardest because this is where we let y equal 0, which means set the whole thing equal to 0. So 2x over x minus 2 equals 0. We're going to get rid of our fraction the same way we always do. Multiply by the denominator. That gives me 2x equals 0. I divide by 2, and x equals 0, which means that my y-intercept, if y was 0, x is 0, I just found the x and the y-intercept also, didn't I? By letting x be 0. So the y-intercept is also the point 0, 0. So here is my x-intercept, and here is my y-intercept. So that one wasn't as hard as I first thought. It might be. So let's look at the next one. From the linear function given, determine the slope and the y-intercept, the graph of the function, and the average rate of change. Well, what do we know about the average rate of change? It's the same thing as the slope. So this is actually a really easy one. And it's already in y equals mx plus b form. So the slope is -1. The y-intercept is the point 0.06. Graphing it, we'll do that in just a second. The average rate of change is the same as the slope. So let's use this to graph it. So I have the point 0, 1, 2, 3, 4, 5, 6. It's right there. -1 over 1 means down 1, right 1. So down 1, right 1, and my line looks something like this. That was a very easy problem. All right, this last one takes up the whole back page. Last couple. Last two, actually. So number 21 says, the monthly cost C in dollars for international calls on a certain cellular phone plan is given by this function, C of x equals, and there it is, where x is the number of minutes used. What is the cost if you talk on the phone for 50 minutes? Well, all that means is put a 50 in for the x. So C of 50 would be 0.38 times 50 plus 5. Do that in your calculator, and you're going to see that C of 50 is equal to $24, because this is going to be 19 plus 5. So that was easy. Suppose that your monthly bill is $29.32. How many minutes did you use the phone? That's the opposite. That's saying take this equation and set it equal to $29.32 equals 0.38x plus 5. Let's subtract a 5. 24.32 equals 0.38x. Divide by 0.38, and you end up with x equals about 64 minutes. That was just a simple calculator problem. Suppose that suppose that you budget yourself $60 per month for the phone. What is the maximum number of minutes that you can talk? Now we got to think about what that means. What it means is, when is C of x less than or equal to 60? Because you can't go over. It can be 60, but you can't go over. So when is 0.38x plus 5 less than or equal to 60? And now you just solve that. We subtract a 5, we get 0.38x is less than or equal to 55. We divide by 0.38, and you say you will not go over your budget when x is less than or equal to 144.7 minutes. Now let's think about it. They're going to round that up to 145, they being the phone company. So we're going to have to say that x must be less than or equal to 144 minutes because you can't round that up. It'll go over 60. Last problem. Suppose that the quantity supplied, which we call S, and the quantity demanded, D, of t-shirts at a concert are given by these functions, where P is the price of a t-shirt. Find the equilibrium price for the t-shirts. That's when the two are equal. So the equilibrium price is when supply equals demand. So we say negative 200 plus 50p equals 1,000 minus 25p. I'm going to add to get my variables together. In fact, I'm going to do this in one step. And I get 75p equals 1,200. And now we are going to divide by 75. And we get that the equilibrium point is when P equals $16 for the t-shirt. Then it says, what's the quantity? So all I have to do is put that into either one. It doesn't matter which one. I'm going to put it into D of P. So what is D of 16? It's 1,000 minus 25 times 16. Or 1,000 minus 25 times 16 is 400. And what you end up with is 600. So that is the equilibrium quantity when the equilibrium price is $16. Determine the prices for which quantity demanded is greater than quantity supplied. So we want to know when is D of P greater than S of P? And that's what you're going to do, is set that up. When is 1,000 minus 25p greater than negative 200 plus 50p? Again, I'm going to do the same thing I did on the last one when I set them equal to each other. So I have 1,000 is greater than negative 200 plus 75p. I added 200 to both sides. I get 1,200 is greater than 75p. We divide by 75, and that gives us, when you divide by 75, 16 is greater than p. But we know that with an inequality, you have to turn that whole thing around. So when p is less than 16 dollars, the demand will exceed the supply. Well, gee, doesn't that make sense? If you're going to sell them cheaper than the equilibrium price, then more people are going to want them. So that's common sense.